So to start with, I'd like you to solve this for y. That is a critical piece. You'll have to do that during the test. If you're not good at it yet, we need to get you good at it. So everybody try this one. We're just solving for y. Awesome. Somebody's done already. Just one step at a time. Olivia, can you tell me the first step? Do the first step? You subtract something.
7x.
Yes, subtract 7x. And then I have negative 3y equals negative 7x minus 33. Hazel, can you tell me the next step?
You divide by -3.
Yep. And do you get why some people get confused about the slope because the x is kind of stuck in there with it? And there's two negatives. Kieran, what happens to the negatives?
The negatives cancel themselves out.
Yep, they're both gone. And then is the slope 7x over 3? No. The slope is just the numbers. So what's the slope?
7/3.
7 over 3. So I'm going to write it out. Y equals 7 over 3 x. And then what do these two negatives do? They cancel. And that makes positive what? Now this one? Is it 11 or is it 10? It's 11. There we go. And then if you had to graph this one, wouldn't it go through 11? 11 is the y what? The y-intercept. And then you'd go, what's this part of the slope? The what? The what over the what? Rise over run. Very good. So you'd start at 11, and you'd rise 7, and you'd run 3. What if I had a less than sign? Or how about a less than or equal? Would it be a solid line? Because of the or equal, it would be a solid line. And then last but not least, would I shade under it or over it? If it's less than, everybody write less than is, and you fill it in. Do you think you shade under or over? Turn it my way and I'll tell you if you're right or not. Okay. Yep. 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 And some people said under and some people said below. Less than is under or below. Cell phone goes in your backpack or up on the rail in a moment if I catch you using it. Okay. So under or below. Okay. So if you're less than something, you're below it. So imagine for a moment one of yesterday's problems was y is less than or equal to 2x plus 3, and y, after you solved it, was greater than or equal to just x. How the heck would you graph just y equals x? Wouldn't that be like x plus 0? Wouldn't that be the same thing as just y equals x? Okay, so then where's its y-intercept? All right, everybody right now, I think you're going to be capable of this. I'd like you to pull up graph paper onto your device. And I'd like you to graph these two. And this is really important that you can do a system of inequalities and shade it. If I had to bet, I would bet that would be one of the questions on the test because we spent a whole day on inequalities. All right, so I'm going to pause for a second while you do that. Okay, I tried to put in some graph paper, but I ended up just getting this Post-it in the way. So let me see if I can get it out of there. Maybe if I go like this and delete it, there we go. Okay, so I'm going to graph this, unfortunately, without graph paper. But I'm going to go to 0, and then I have a slope of 1, which means like this. Raise your hand if you figured out that it was like that. All right, cool. And is it shaded above it or below it? This sign right here is your key. Does this sign right here mean shade above it or below it? Say it. above. So I'm shading above it because it says greater than. Okay, somehow got a dot in there. Let me get rid of that. Okay, and then I'm going to do one last kind of shading. And that's for the other line. And that line goes through 3 and then has a slope of 2. And which way should I shade on that one? Lydia, what do you say? Shade above it or shade below it on this one?
Below.
It says less than, so that's definitely below. So in which area did it get double shaded? I can see it. Can you see it? It was this area where it got double shaded. Raise your hand if you had that one right. Okay. Now, that wasn't many people that raised their hands, so either A, I did it wrong, but I don't think so. Or B, you guys just weren't in the mood to raise your hand. Or C, a lot of people got it wrong. So I want to say it this way. Be honest. How many of you made some kind of a mistake on this and something went wrong? Oh, so just I was getting the response where people were not sure they should take the time to raise their hand. Okay. So in other words, almost everybody got it right. Yay. What if the answer had been about finding where they cross? Well, then that answer would be like they cross right there. Now, can you tell me, did yours on graph paper end up being at a nice place? It's called a lattice point where two things cross. Did it go exactly at a lattice point? I'm seeing some kids saying yes and some kids saying no. How many of you say yes, it was at a nice logical lattice point? Ooh, a lot of people say yes. All right. Let's see, Stella, what do you say that point was?
-3.
Now, let me show you how you can be sure you're right. If I put -3 in here, it should work. Some kids don't know what work means. It means it should make this statement true. This right here should be true, meaning -3 is really less than or equal to all of this. And all of that would be -6 plus 3 is -3. That is equal to that. So -3 is equal to -3. It's a true statement. See how you can know you're right? You just have to take the answer and stick it in both equations. This one is saying -3 is less than or equal to -3, and that's a true statement. So yay, if it works in both of them, it's your point. Do you get how it'd be powerful on a test to be sure you're right? Because what if you do check it in one of your equations and it's like, crap, it doesn't work in that one? Then you did something wrong. At least it's a big hint to go back and fix it. All right. Now, that's a quick review of a lot of things we've done. For the test, we still have to talk before Friday about substitution, where you solve one of them, stick it in the other equation, and elimination, okay? But otherwise, that helped us practice graphing, and it helped us practice inequalities. So I think that was a good starter. All right, so are there any problems off the homework that you want to ask about? We'll talk more in a bit. All right, then let's get to this page right here. And I'd like you to look at this equation. I've got two completely different graphs, but in some ways they're similar. One's red, one's blue. That's not similar. One's got a dotted line, one's got a solid line. That's not the same. Is there anything about them that is the same? No?
I believe they're both less than.
All right, they're both shaded underneath. I agree. They're both less than. Okay. Are they both or equal to? No. One of them is, one of them isn't. So equal to is how they're different, because one of them's equal to, one of them's not. Do they have the same y-intercept? It actually looks kind of close. The y-intercept is 2 on the red one for sure. On the blue one, I feel like the y-intercept is more like 3. So I think that their y-intercept is different. All right. Let's actually do one more graph. And I like this one because it's going to make you solve it a little bit first. So graph this system. Show me that you've been paying attention and that you understand how to do this stuff. This one we already practiced. It's kind of like this line, oops, except it goes through 0, 0. Well, the line y equals x is just a nice, simple 45-degree angle line. But this time, it's not equal to, it's greater than. All right, so graph that system, and in a moment, I'll come around and check you. Okay, this time, I'd like you to turn and show your graph carefully. Take your time and make sure that you agree on where it crosses. If you haven't already, figure out where these two lines cross. Do they actually cross on the graph? Or are they off the graph where they cross? Just tell me. Are they off the graph or on the graph? I don't know. Nobody knows the answer to that question? Do these two lines cross?
On the graph, I believe.
Okay. Would you agree that one of the lines runs like this?
Yes.
Okay. The other line, the only question then is, does this line? Well, I'm going to subtract 5 from both sides, and then I'm going to multiply that whole thing out. Negative 3x minus 6 minus 5. Negative 3x minus 11. How many of you guys got the same thing as me on that one? Okay, good. Then, if it goes through negative 11, it's just off the graph. That kind of stinks, but it's going to be okay because our first point, we can make it go back up on the graph. And it'll go through it'll rise 3. Normally, I would say go down 3 and over 1, but that'd be down here, and it'd be really hard to tell where it's going. So I'm going to go up 3 and to the left 1. Up 3 to the left 1. Up 3, oh, I feel like it just missed. And I could be wrong on this, but if it hits there, they clearly cross, but it doesn't look like they cross at a nice spot. Do you get what I mean? All right. It's hard for me to tell when you guys are being kind of quiet like you are right now. I feel like you're getting it, but I can't quite tell. How about this? Should that line be solid or dotted? Should one of these lines be dotted? Yes. The red one or the black one? Red one should be dotted line. Dot, 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 dot. Okay, and then I should be shading some places, right? Underneath the red line or over the red line? Under or over this one?
Over.
Greater man means over, you're right. So I'm going to shade just a little bit on this side of the line. That's the way I recommend doing it. I know some of you like to paint all the way to the edges of the graph. I don't think it's the easiest way. I think the easiest is just shade a little bit in that direction. And now the other one is greater than, which means also over it. And I think it's easiest to tell where they overlap by doing that. There's my answer. And the intersection point, that would have been hard to describe because it wasn't exactly on a lattice point. So in other words, it was a fraction or a decimal. Raise your hand if you feel like you would have got this one right. All right, cool. Then, let's take a look at how this could be applied in the real world. So, there is something called supply and demand. Do you get, if the price of something goes down, more and more and more people will want it? Isn't that generally true? I mean, if the thing is something you'd want, like, I don't want a disease, the price of it goes down, I'm not gonna want it. But like, if it's something good, like, I don't know, a flat screen TV or something, the price goes down, more and more people will say, yeah, I'll take one. In fact, some people will start saying, if the flat screens are that cheap, I'll have one in every room in my house. And that's kind of what's happened. Flat screen TVs have gotten really cheap. You can get them for only a few $100s now if you are willing to take one that's not huge. But you can get tiny little flat screen TVs really cheap. So can you imagine a day where a room like this could have like 8 flat screen TVs all squished together instead of a monitor like this that costs like $3,000? Can you imagine we might have a whole bunch of flat screen TVs? That's one of the things they're thinking about doing. Especially if the flat screen TVs can go right to the edge, because then do you get how you could get them to like go next to each other and it would like look like it's one big monitor? So anyway, that's one of those ways that the world could change over time. Yes?
Can't you set it up so that they all are like one monitor, just with different display segments like you can do with
Yes.
laptops?
What all I was trying to say, you can get them to coordinate to be like, I'll make this monitor be the upper right-hand corner of the picture. But right now, there's like a border, you know, but as you may have noticed on cell phones, the border is getting smaller and smaller and smaller. It's called a bezel. And so the bezels around the edge of the screen are getting so that sometimes phones don't even have a bezel anymore. And so, meaning that it goes all the way to the edge of your phone. You know what I'm talking about? So when that happens to big screen TVs, which it's kind of moving that way, then pretty soon you'll be able to put your big screen TVs right next to each other and it'll look like you got one giant monitor. Because those giant monitors are really expensive. Like the ones in the dome, the football games and stuff, those could be like $1 million. Well, if they could make them out of a whole bunch of little monitors, that would be really cheap. So someday that'll be more of a reality. Okay, so anyway, there's supply and demand and the price goes down and then there's more supply. There's more demand if the price goes down. All right, so this is an example of a graph where you've got supply and you've got demand. And this is what they call the equilibrium price. That's where the supply and the demand meet. Like the amount of people that want to buy one is like the demand, and the supply of them is the same. What if you've got a lot more of something than people want? Like, crap, we bought 1,000 black t-shirts and we only sold like 200 of them. Now we got 800 black t-shirts left over. Do you get how if there's a lot of them, then the price has to go down? If you've got a ton of them, you got to mark them down to get rid of them. Okay, so this is an example of how somebody might use these kind of graphs in the real world. All right, so when we're doing something called linear programming, we're trying to find the optimal solution to the problem given a set of constraints. For example, let's say that a toy manufacturer wants to maximize their profits. Do they do that because they're evil? No, they're a business, they're trying to make money. That's why they have their store open or their manufacturing place. They're trying to make money. If they make money, they can pay their employees and then it rewards whoever made the company with some profit. So Apple, for example, most of you guys have an Apple phone. They make a profit on those phones. It costs them way less to make this phone than they sell it to you for. And what do they do with the profits? Well, one of the things is they research and try to figure out new products that they haven't made before. That's called research and development. That's one thing you can do with your profits. All right, so anyway, here's constraint 1. Imagine that they're making little toy cars and little toy tractors. And let's say that they use the same type of wheels and they only have so many wheels. If you only have so many wheels, then you can only make so many cars and tractors. And if you make more tractors, then you'd have to make less cars. Okay, so that'd be a real world constraint where you only have so many tires. Does this happen in the real world? Yeah, right now, for instance, The reason that they're having so much trouble selling cars, there's a lot of people that want to buy a car right now. And then there's a lot of car makers that don't have any cars to sell them because they're missing the chips. Have you guys heard about this? That a lot of cars are missing the silicon chips, yep, that like are made by chip makers. And the chip makers are like, sorry, we don't have any. We haven't got enough. Again, they blame the car makers for not ordering enough during the pandemic. And the car makers were like, well, we didn't need them during the pandemic. And so anyway, long story short, they don't have enough chips. So they can't make the cars. So actually for a while, you saw pictures of huge parking lots full of cars that didn't have the chips in them. Because they were just waiting till they got the chips and then they could stick the chips in and then the cars would work and then they could sell them. So that's an example, real world. This we're talking about wheels on tractors, but in the real world, they're short of chips. And that's constraint. And that means even if you wanted to build more cars, you just can't because you don't have enough chips. Constraint number 2 for us, there's a limited number of hours each week that the company can use to produce the items. Do you get if your boss says, hey, I want you to work 2 shifts, you might be able to pull that off like a couple times, but what if your boss wanted you to work 24 hours a day? You'd be like, no, I don't want to. I don't even want to work 2 shifts, but if you maybe pay me a lot, maybe I'll work a double, it's called, where you work 2 shifts in a row. But there's a limited number of hours that you can work. All right, and the last part, optimizing profit. They make more money selling tractors than toy cars. Do you get, though, that sometimes it's not a smart decision to say, so we're only going to make tractors? You know what I mean? Like, what if Apple originally made the most money on computers? And they were just like, so we're only going to make computers. We'll not even mess with phones or selling music online or all the other things that they do. If they made the most money on the one thing and that's all they did, that would be kind of dumb. Sometimes you want to do some stuff even if it doesn't make you the most money. All right, so.
Something to fall back on, 'cause if, say, the computer suddenly failed and some
Yeah.
company had a supercomputer, then they would be out of business because they have nothing to fall back on.
Very good. And sometimes your business is about like if you're a grocery store and you make the most money on selling vegetables, can you be the grocery store that only sells vegetables? Nobody wants to go to a grocery store that only sells vegetables, right? So you have to have the other things sometimes. Depends on your business, but okay, enough about that. So let's say, can you imagine a scenario where it was shaded underneath this line for one of the constraints, that might have been like the wheels, and you can shade it under this line, which might have been like how many hours you can work. Then this thing that's left is the shaded area, and those are the only things possible. Why didn't they go underneath this line? Because you can't have less than 0 and like have negative hours of work. And you can't have less than 0 tires, right? So in the real world, you have to stay above 0. For most things, isn't that true? There's always the exception, but there's most things you can't have negative. This year we're going to make negative number of iPhones. You can't do that. You can make 0. Okay, so this area is our possible answer. And let me tell you that the optimized answer is one of those orange points. Only one of those points can be the final answer. And usually you optimize for profits. But like I said, even though this one might make you the most profit, in the real world, a lot of times you don't pick that one. You pick the one where you make some of each. Because, like Noah was saying, you don't want to be the company that has no backup plan in case this year your phone doesn't sell well when you got nothing else. All right, so I think this one is often the right answer in the real world. But maybe this one, it's still, as the boss, wouldn't you like to know, oh, we could make the most profit doing this, or we could make the most profit doing this. The other example is selling 0. That's never the best answer. Because if you have a choice that makes you money, it's not likely you're ever going to choose to make 0 of something, or the whole point is like there's no point in having a company if your best answer is to sell 0 of something. All right, so here's a real world problem. And remember me saying at the beginning of the hour that to be able to do all of this together would be like the R4. So just one little part of it though, you'll have to be able to do each little part as a separate question. But if we put it all together as one problem, and you had to shade under this one and shade under that one and find that region, and then of the region, pick the right corner that gives you the most profit, that would be so intense that it would be an R4. All right, but I could actually expect you to answer A. Well, I've got one little piece at a time. Let's just talk about, I could expect you to answer each little piece. Each standard board requires 6 labor hours for fabricating and 1 labor hour for finishing. So 6 X's plus, can anybody finish it? 1 Y. You get how I did that? 6 of the one and 1 of the other. Okay. Apparently we're making standard surfboards and competition surfboards. Each competition board requires 8 hours of fabricating, 8 X's, and 3 hours of finishing. So there's 2 equations. The maximum labor hours available per week are 120 for fabricating. Which one was fabricating again? Fabricating was the first kind. That was the X kind, was fabricating. So X has to be, I'm going to do this wrong on purpose. Think about this. Greater than 120. No. Which way should it be? Less than or equal to 120. Very good. And then write the one for finishing. Be ready. Call on anybody here.
Plus 30 Y.
30? 30 is the finishing, and it has to do with Y, but I think we want to say something about Y and 30.
Y is less than or equal to 30.
There you go. All right. The company profits 40 for each standard board. 40 for each standard board. I'm going to call that 40 for each B. And 75 for each competition board. There's boards and competition boards, so I usually call them B and C. And this is profit. That might have been the trickiest one. That's our 15-minute warning. Now, there's an example of a whole problem and something that would be a little bit too much to ask of you on the test. But any one little piece of that we could ask you to do. It's like write this equation. You should be able to write an equation. Write an equation where it has to be less than 120 hours. X is less than or equal to 120, that kind of thing. All right. So, for the rest of the class, this last 15 minutes, it's our homework. And our homework is the search and rescue worksheet. Help us find Harold. All right, so everybody see if you can find the worksheet that's posted for today. I'm going to pause for a second while we do that. Okay, so do you see the map that's got Australia prominently in the lower left-hand corner? Raise your hand if you've got that up on your iPad already. All right, seems like most of you have it. Find the map that has Australia on it. It's basically the worksheet. Okay, so we're supposed to shade in the region on the map and then write out the system of inequalities. Your team, well, that's basically you, must determine where to send the search and rescue teams. Okay, so basically there's a whole lot of places these guys could be lost. And you're going to kind of narrow it down to a region. Use the following reports along with the map. Look carefully for information that will help you draw constraints on where the balloon might be found. Give the search constraints to the search and rescue team and as a system of inequalities. Be sure to identify the landing site on the map. Okay, let's try to write an equation for this first one. It says the basic facts of the case. The balloon departed from the airport at the very northern tip of the Philippines. Do you see the spot on the map where they even have a dot there? Do you see that? Right above Philippines, there's a little dot. Okay. The flight was supposed to follow a straight path directly to an airport in French Polynesia. Do you guys know which of those are in the French Polynesian islands? You see them way off to the right? It was supposed to go there. So it's supposed to be a straight line that goes from the one to the other. The balloon's last known location was at -1,000, 1,000. Oh, that'd be important. Put a dot there. And maybe you should draw a straight line between the Philippines dot and the French Polynesian dot. I think I'm doing too much of this. This is your job, to try to draw out the lines in the right place, and I would bet there's going to be shading under them in some spots until you get a final like, oh, it must be here. And I could be wrong. It's possible there is no shading. But I do see something in the directions that's like, I saw it going down to the north of where we were flying. That to me seems like shade in. North of one of your lines. Okay. It'll ruin it if I do the rest for you, so that's all I've got for you. Good luck.